Welcome, dear listener. Tonight, I invite you to lie back, close your eyes if you like, and let your breath fall into a natural rhythm. You are safe here, in this quiet corner of the universe where there is no rush to understand and no pressure to remember. We are about to explore quantum physics, not in the hurried way of textbooks or laboratories, but slowly, softly, as though each idea were a feather drifting on still air. Quantum physics is often described as strange, mysterious, even overwhelming. But here it will be boring. Boring in the best possible way. The kind of boring that relaxes the mind, lets curiosity hover gently in the background, and allows sleep to arrive as naturally as the night. And if you find comfort in these journeys, if you enjoy drifting into rest while learning something small and simple about the cosmos, I'd love for you to subscribe to the Wandering Neuron. Together, we'll wander through science and dreams, finding peace in both. Now, let's take our first step into the tiny, quiet world beneath all things. At first glance, the world seems solid. The chair beneath you, the floor holding your weight, the stars shining far away, everything appears firm and reliable. But quantum physics begins with whispering, this is only an illusion of scale. When we look closely, so closely that we go beyond the reach of ordinary sight, we discover that matter is not solid at all. Instead, it is mostly empty space, dotted with tiny entities we call particles. Imagine shrinking yourself down, smaller and smaller, past the cells of your body, past the molecules that form those cells, past the atoms that make up the molecules. At the heart of the atom lies a nucleus, itself made of protons and neutrons, which in turn are made of quarks. Around this nucleus swirl electrons, impossibly small and elusive. But here is where the boredom of quantum physics begins. These particles are not neat little billiard balls. They are better described as probabilities. They exist in clouds, smeared out regions where they might be. You can't point and say, the electron is right here. Instead, you must accept that it exists as a possibility until you disturb it. This, for many, is the first shock of quantum physics. But for us tonight, it is simply a soft thought. Picture a gentle mist, drifting, shapeless, and quiet. That is the electron's world. Not a point, but a haze of potential. And when you let that image settle, notice how calming it becomes. The solid world dissolves into mist, into openness, into something almost like a dream. Now, if particles are not neat little dots, what are they? Here, quantum physics offers us another soothing contradiction. Particles are also waves. The famous double-slit experiment showed this in a simple but profound way. Shine light through two slits, and instead of two bright bands forming, as you'd expect from particles, you see many bands, a wave pattern. And yet, if you look closely enough, the light arrives in little quanta, like tiny packets. This is wave-particle duality. Light, and indeed all matter, behaves both like a wave and like a particle, depending on how you observe it. For the sleepless mind, this might sound puzzling. But let's imagine it more gently. Picture the ocean. Each wave is spread out, rolling smoothly. But imagine that when the wave touches the shore, it arrives not as water, but as a single pebble. Smooth waves delivered as tiny points, both wave and particle at once. And what does this mean for us drifting here in the dark? It means that reality itself resists our attempts to pin it down with simple categories. The universe, at its smallest scales, prefers to blur boundaries, to mix opposites. For the restless mind, this might stir confusion. But for the tired mind, it is soothing. Because if reality itself refuses to be one thing or another, then perhaps we too can rest in uncertainty. We can allow ourselves to be both awake and drifting, both curious and ready for sleep. In this sense, quantum physics is not exciting. It is quite wonderfully boring. A steady rhythm of waves and points, a lullaby written in mathematics. The next idea is perhaps the most famous in quantum mechanics: Heisenberg's uncertainty principle. It tells us that you cannot know both the exact position and the exact momentum of a particle at the same time. The more precisely you try to know where it is, the less precisely you can know how it is moving. And the more you know about how it is moving, the less you can say about where it is. At first, this may seem frustrating, but think of it another way. The universe has built uncertainty into its foundation. It is not an error of our instruments, but a property of reality itself. Imagine standing by a window in a quiet room at night. You see fog outside, drifting slowly. You know it is there. You know it is moving. But to say exactly where each wisp is at this moment would be impossible. The fog resists precision. Particles are like that fog. Not wrong, not broken, simply unwilling to be fixed in one place with perfect clarity. And isn't that, in a way, comforting? Life itself often feels uncertain. Our plans, our dreams, even our moods shift and blur. But quantum physics tells us this is not a flaw. It is the very fabric of the world. Uncertainty is natural. So tonight, as you let your eyes grow heavy, perhaps you can let uncertainty be your companion. You don't need to know exactly how sleep will arrive or when. You don't need to hold yourself still in perfect clarity. You only need to drift, as particles drift, in the gentle blur between knowing and not knowing. If uncertainty was strange, superposition is stranger still. In quantum physics, a particle can exist in more than one state at once, until we observe it. This is called superposition. Think of a coin tossed into the air. In our everyday world, the coin is either heads or tails at every instant. But in the quantum world, the coin is both, heads and tails together, until you look. This is not a metaphor, but a feature of reality at its smallest scales. Electrons, photons, even atoms can exist in overlapping possibilities, spread like soft colors blending in watercolor paint. And then, when observed, the superposition collapses into a single outcome. The many possibilities condense into one fact. You may have heard of Schrodinger's cat, that famous thought experiment where a cat is both alive and dead until someone opens the box. It was never meant to be taken literally, but as a way to show how strange superposition seems when scaled up into our world. But let's think of it more gently. Imagine listening to a chord of music, three notes sounding together, blending, vibrating. That is superposition, a harmony of states. And then, at some quiet moment, the chord resolves into a single note. Not abrupt, not frightening, simply the universe choosing one thread from many. And what does this mean for us tonight? That possibilities can rest beside each other, peacefully, until the time is right. That we don't need to rush to collapse every choice, every worry, every thought. We can let them hover like soft chords in the air, drifting until sleep chooses one path for us. If superposition whispers that a particle can be many things at once, entanglement whispers something even more curious. Particles can be deeply connected, even across vast distances. Two particles can become entangled, meaning their properties are linked. Measure one, and the other responds instantly, no matter how far apart they are. Einstein famously called this spooky action at a distance because it seemed to defy the speed limit of light. Yet experiments have shown again and again that entanglement is real. But let's not rush into the mathematics. Let's imagine instead a pair of dancers. They begin together, moving in perfect rhythm. Then, separated, they drift to opposite sides of the stage. And yet, when one raises a hand, the other responds in harmony, as though the music still connects them. Entanglement is like that dance, a quiet thread of unity beneath the surface of separation. And for the tired mind, this is not a puzzle to solve, but a comfort. Because if even particles can remain bound in subtle ways, then perhaps distance in our lives is not so absolute either. Perhaps we too are quietly connected to people we love, to the earth, to the stars themselves. As you rest tonight, you might imagine yourself entangled with the universe, not in a grand, dramatic way, but in the softest sense, a shared rhythm, a silent harmony, like a lullaby between you and the cosmos. Now we arrive at a curious question. What role does the observer play in quantum physics? In classical physics, observation is passive. We look at the moon, and the moon remains unchanged by our gaze. But in the quantum world, observation matters. When we measure a particle, its wave of possibilities collapses into one reality. This does not mean that consciousness magically controls particles, but it does mean that interaction, the act of observing, changes what can be known. Imagine a pond at dawn. The surface is still, holding perfect reflections of trees and sky. But the moment you touch it, even with a fingertip, ripples spread, changing the image. You have not destroyed the pond, but you have changed what is revealed. So it is with particles. To observe them is to disturb them. To look closely is to change the picture. And here, too, lies a gentle thought for sleep. Not everything must be pinned down by our constant attention. Sometimes, reality reveals itself only when left unmeasured, unpressured, free to drift. As you close your eyes tonight, let the world exist without your constant gaze. Let the ripples settle. Let the pond be still. Let the particles of your day collapse quietly into rest. Imagine you are standing before a wall. In the everyday world, if you don't have a door or a ladder, you cannot pass through. The wall is solid, unyielding. But in the quantum world, particles sometimes do something unexpected. They tunnel through barriers. A particle faced with an obstacle it should not cross sometimes appears, mysteriously, on the other side. This is called quantum tunneling. It sounds impossible, but it is real, and it happens constantly at the smallest scales. Without tunneling, the sun itself would not shine, for the fusion reactions at its core rely on particles slipping through barriers they could never otherwise overcome. To picture it gently, imagine a moth brushing against a closed window. In our world, it cannot pass through. But in the quantum world, now and then, the moth would simply appear in the garden beyond, wings fluttering in freedom. This strangeness is not violent, not dramatic, it is quiet, almost unnoticed, and yet it powers stars. For us, tonight, tunneling can be a reminder. Sometimes what seems impossible is only improbable. Sometimes the barriers we face are not as fixed as they appear. And as we rest, we might let go of the walls in our minds, trusting that the universe knows secret paths through them. In our everyday computers, information is stored in bits, tiny switches that are either on or off, 1 or 0. Every word you read, every song you hear, every image you see online is built from billions of these bits. But quantum computers are different. They use qubits, which can exist in superposition, both 1 and 0 at once until measured. And when qubits become entangled, they can work together in ways that ordinary bits cannot. This allows quantum computers to explore many possibilities simultaneously, solving certain problems far faster than any classical machine could. But let's not imagine glowing machines filled with wires and cold steel. Instead, picture a quiet library at night. In an ordinary library, you must search each book one by one. In a quantum library, the shelves themselves whisper the answers, as though the books exist in many states at once. For most of us, quantum computers will remain abstract, distant. But in the calm of tonight, they become simply another lullaby of possibility. Machines that hum with the strange music of qubits, working in silence while the world sleeps. Perhaps the strangest thought of all is that quantum effects may not belong only to the cold, empty vacuum of space or the sterile world of physics labs. They may live within us, too. Some researchers believe that photosynthesis, the way plants capture sunlight, relies on quantum coherence, allowing energy to move with near-perfect efficiency through tangled networks inside leaves. Others wonder if birds use quantum entanglement to navigate Earth's magnetic field, guided by invisible threads as they migrate across continents. There are even whispers that quantum processes may play a role in the brain, not as magical explanations, but as subtle influences in the way neurons interact. For us, lying in the dark, this idea is soothing. Life itself may be tuned to the quiet strangeness of the quantum world. The greenness of leaves, the flight of birds, even the sparks of thought in your own mind, all may carry echoes of particles in superposition, entangled across time and space. It is not certain. It may never be certain, but like a half-remembered dream, the possibility itself is enough to calm the restless mind.
And so, as you breathe deeply and allow your body to soften, imagine yourself as part of that quantum dance. Every cell a quiet miracle, every thought a ripple in probabilities, every heartbeat in tune with the most mysterious laws of nature. Imagine for a moment that deep inside your chest, your heart is not only beating, it is listening. Each cell, each rhythm, each wave of electricity is a quiet conversation, a whisper of life's code. But what if the heart is more than just a pump? What if it is a subtle chamber where entanglement dances, unseen yet binding? When two particles are entangled, distance means nothing. One moves, the other stirs. One trembles, the other echoes. Scientists wonder if, inside our bodies, this mystery may help synchronize the astonishing precision of life's rhythm. In your heart cells, ions drift in and out, tiny charged particles carrying signals. If entanglement weaves through them, then perhaps the heart beats not only from muscle and electricity, but also from the silent agreement of particles that are joined, an invisible orchestra conductor keeping time. As you rest now, imagine your heartbeat as a lantern in the dark, pulsing gently. Each beat radiates out like ripples across a pond, and maybe, just maybe, those ripples connect you to something far beyond yourself, a rhythm that belongs not only to you, but to the universe itself. Let us drift northward into the wings of a bird. Migratory birds, fragile and small, travel thousands of miles across oceans and continents. How do they find their way? Guided by nothing more than the sky and an inner knowing. Here enters one of the most enchanting theories of quantum biology. Inside the eye of a bird lies a molecule, a delicate receptor where electrons exist in two states at once, a shimmering quantum superposition. This fragile state is influenced by Earth's magnetic field, like a compass etched not in metal, but in the very quantum fabric of life. The bird does not think, I must calculate the field lines, the magnetic pull. It simply feels. It simply knows. Quantum whispers guide it across the unseen grid of the planet, allowing feather and bone to trust the map of the earth itself. As you breathe now, imagine this compass glowing softly inside you too. For we are made of the same dust, the same particles, and perhaps somewhere within, the earth hums quietly to us as well, reminding us of home, of direction, of belonging. Now let us turn to the silent green world, to the forests, to the leaves that flutter in twilight. Plants, with their calm stillness, are great magicians. They take sunlight, golden, weightless light, and transform it into life's food. But here lies the secret. When photons strike a leaf, they do not stumble blindly, choosing a random path like wanderers in the dark. Instead, they slip into quantum coherence, moving like a wave that explores all possibilities at once, choosing the most perfect, efficient route to the heart of the cell where energy becomes nourishment. It is as though light itself dances with purpose, finding the most elegant step in a vast ballroom of possibilities. A photon is not hurried, not clumsy. It glides with the grace of something that already knows the way. And so, every forest you have ever walked through, Every tree that has ever shaded you, every breath of oxygen you have ever taken is a gift of quantum choreography, a dance of particles weaving matter out of sunlight. As you drift deeper into rest, imagine leaves glowing softly in the night, breathing with you, their quantum breath entwined with yours, life and light folding quietly into your dreams.
Imagine, for a moment, a quiet forest at dawn. The first beams of sunlight drift gently through the canopy, scattering into emerald patterns. Each leaf becomes a living panel, capturing light not just as energy, but as information, whispering in a language older than words. Here, in this green cathedral, plants perform a subtle act of alchemy. They do not merely drink in light, they choreograph it. Photons, those tiny messengers from the sun, do not travel alone. Instead, they spread themselves out, taking every possible path across the web of a plant's molecules, searching for the most efficient route. This is quantum superposition, playing out quietly in every leaf. It is as if the plant holds a map that constantly redraws itself, each photon testing all the roads at once, before settling into the shortest path home. A journey completed in trillionths of a second, yet repeated endlessly, sustaining forests, meadows, and oceans of plankton. The great rhythm of photosynthesis, the very breath of Earth, relies on this quantum gift. Without it, the world would be dimmer, quieter, hungrier. Instead, the leaves hum with abundance, and life blooms from light. Now let us follow a bird in flight, wings stretched against the sky. A robin, perhaps, migrating across unseen continents. No map, no compass, no glowing trail. And yet, it knows the way. The secret lies not in its eyes, but deep within them. A delicate protein called cryptochrome holds a radical pair of electrons, partners bound in an invisible embrace. As the bird flies, Earth's magnetic field nudges these electrons ever so slightly, shifting the rhythm of their spin. This tiny quantum dance whispers directions to the bird's nervous system, letting it see the invisible, the planet's magnetic lines painted faintly across the horizon. And so, from Europe to Africa, from pole to pole, these fragile quantum whispers guide the great migrations. The monarch butterfly tracing ancient paths, the sea turtle returning to the beach of its birth. Even the honeybee, buzzing between flowers, carries within it this hidden compass. We too are travelers, and perhaps within us are echoes of these same quantum instruments, small reminders of how deeply we belong to this earth. Now let us drift inward, into the quiet cathedral of the mind. Billions of neurons glimmer, weaving sparks of memory and thought. At first glance, it seems only chemistry and electricity at play. But some scientists whisper another possibility, that quantum effects flicker within the brain's deepest machinery. Microtubules, tiny filaments that scaffold our neurons, may hold vibrations so delicate, so finely tuned, that they can exist in quantum states. If this is true, then your thoughts, your dreams, even your awareness of this moment may ripple with quantum coherence. It is as though the mind does not simply generate consciousness, but resonates with the universe at its smallest scales. A quiet tuning fork struck by the cosmos. And so, every flash of insight, every remembered name, every dream before waking may not be only a product of neurons, but also a shimmer of quantum whispers. Subtle, fleeting, but real enough to make us wonder. Here, at the border of science and mystery, quantum biology suggests that life itself may be a tapestry woven of probabilities collapsing into the certainty of a heartbeat, a breath, a thought. Imagine sound, not as a simple wave traveling through the air, but as a tapestry woven from trembling threads of quantum energy. Every note, every whisper, every rustle of leaves carries not just a vibration, but a quantum fingerprint. Some scientists believe that our sense of hearing, especially at the finest scales, may rely on quantum tunneling. Deep inside the inner ear, the cochlea bends sound into sensation. Within its spiral, hair-like receptors must detect movements smaller than the width of a single atom. The classical world struggles here. Too much noise, too much chaos. Yet somehow, our ears remain sensitive to the faintest crack of a twig or the soft sigh of the wind. It may be that quantum tunneling allows charged particles to leap across gaps within the auditory cells, bridging spaces that ordinary physics says should remain silent. Like a musician who can hear the faintest overtone hidden in a symphony, our ears may borrow from the quantum realm to stretch their sensitivity. So the next time you listen to a lullaby, to rain against your window, or to the voice of someone you love, imagine the delicate dance of electrons and vibrations, quantum whispers made audible. Life is not just listening to sound, it is listening to the universe's smallest secrets. And then we arrive at the most mysterious frontier of all, the human mind. For decades, philosophers, neuroscientists, and dreamers have asked, could consciousness itself be quantum? The brain is a restless sea of electrical signals, billions of neurons firing in patterns as intricate as constellations. Classical explanations suffice for much of what we know. But consciousness, the feeling of awareness, of I am, still drifts beyond the reach of equations. Some researchers, like Roger Penrose and Stuart Hameroff, have proposed that within the microtubules, the tiny scaffolding structures inside neurons, quantum processes may be at play. In this view, the mind is not just an emergent pattern of firing neurons, but a symphony orchestrated at the quantum level. Whether or not this theory holds true, it reminds us of something profound. The brain is not merely a machine, but a mystery, perhaps one that straddles the border between physics and philosophy. If quantum coherence shapes our thoughts, even fleetingly, then every moment of awareness may be a small miracle of the universe's deepest laws. And when you dream, drifting in that twilight place where time bends and meaning ripples. Perhaps you are feeling the quiet pulse of quantum possibility itself. Beneath the skin, beyond the reach of conscious thought, the body is always repairing, always tending to its quiet gardens of life. Cells divide, DNA unwinds and copies itself. Proteins fold into shapes as delicate as origami. And here, too, quantum mechanics may lend its subtle touch. When DNA is damaged by sunlight, by stress, by the simple wear of existence, repair enzymes must find and fix the errors. The puzzle is vast. Within billions of base pairs, how the repair systems locate a single mistake. One theory suggests that quantum superposition guides the search, allowing the repair machinery to sample multiple possible sites at once, collapsing only when the damaged spot is found. Like a lantern that illuminates not one path, but many, quantum rules may make healing efficient, almost effortless. Proteins, too, fold with impossible speed. From a tangle of amino acids, they twist into precise shapes that determine the chemistry of life. The process seems far too fast for classical trial and error. Quantum tunneling may allow molecules to leap into their correct arrangements, avoiding endless false starts. Healing, then, is not just biological. It is quantum. Every scar that fades, every cut that closes, every cell that renews itself carries the signature of physics at its most delicate scale. And so your body is not merely surviving. It is quietly dancing with quantum laws every moment of every day. Have you ever wondered how a single whiff of jasmine can carry you back to a summer evening from years ago? Or how the faint aroma of fresh rain can stir emotions too deep for words? The world of scent is far more than chemistry. For decades, scientists believed our noses only worked by shape, that odor molecules fit into receptors like keys into locks. But there was a mystery. Molecules with almost identical shapes sometimes smelled entirely different. Here, quantum biology enters with a whisper. Some researchers propose that our noses listen not just to shapes, but to vibrations. Every molecule hums with its own quantum tune, a delicate vibration, invisible yet real. And within our olfactory receptors, electrons may be tunneling in response to those subtle vibrations, making us hear scent as much as smell it. It means that fragrance might not merely be a shape pressed against a receptor, but a tiny song of matter itself, a quantum melody that our brain translates into roses, smoke, vanilla, or pine. The air around you is full of these silent songs, weaving invisible threads between memory and sensation. A perfume bottle, a bakery, a forest after the rain, each one is a concert of quantum notes played softly and fleetingly. And when you inhale, you are not simply breathing molecules. You are listening to the quiet music of existence. High above the ground, swallows migrate across continents, navigating with uncanny precision. Sea turtles return to the very beach where they were born after years adrift in the vast ocean. Monarch butterflies, fragile and light, travel thousands of miles guided by something unseen. For centuries, we wondered, how do they know the way? What compass could they possibly carry? The answer may rest in the fragile realm of quantum entanglement. Inside the eyes of these travelers lies a protein called cryptochrome. It is sensitive not just to light, but to the Earth's magnetic field itself. When photons strike this molecule, they set electrons spinning, creating entangled pairs that respond to the planet's faint magnetic pole. Imagine it. Within the eye of a bird in flight, a tiny quantum dance is unfolding, giving it a faint, ghostly map of north and south. The Earth is whispering its direction, and quantum physics is the interpreter. It is a compass not made of iron or needle, but of fragile entangled states that flicker and fade in mere microseconds. And yet, that sliver of time is enough to guide life across oceans and skies. When you see a flock of geese arrowing across the sunset, or a butterfly resting after its long journey, you are witnessing the invisible threads of quantum coherence stretched across the world. The Earth itself sings, and life listens. Deep within your cells, countless little machines are at work. They are enzymes, nature's silent workers, folding, turning, and guiding molecules with exquisite care. For decades, scientists thought enzymes simply lowered energy barriers by shape and chemistry alone. But then, quantum whispers were heard inside them. Electrons, instead of trudging slowly over a hill of resistance, seemed to vanish from one side and reappear instantly on the other. This is quantum tunneling, a strange permission slip from the quantum world, allowing particles to move where they seemingly should not. In the dance of life, tunneling is everywhere. It allows enzymes to speed reactions that would otherwise take centuries. It lets the machinery of your metabolism hum along like a perfectly tuned orchestra, each instrument playing in time. Imagine your body as a symphony hall. The enzymes are the musicians, and tunneling is the invisible hand ensuring that the bow touches the string at just the right moment, producing music instead of silence. Without tunneling, life's tempo would slow to near stillness. But with it, the symphony flows. Close your eyes and think. Within you, at this very second, countless electrons are slipping through invisible barriers, making you possible. Life itself is quantum music. Take a slow breath in. Notice how the air carries subtle scents, perhaps a hint of soap, fabric, or the memory of food. Your nose, delicate and unassuming, is a quantum detective. For years, scientists believed smell was simply about shape. Molecules fit into receptors like keys into locks. But a deeper truth may be at play. Some researchers propose that your nose listens not just to the shape, but to the vibrations of molecules. Imagine every molecule as a tiny violin string vibrating with a unique frequency. When the molecule enters your nose, electrons in the receptor may use quantum tunneling to listen to those vibrations. If the frequency resonates, the scent comes alive in your mind. This theory explains why molecules of similar shape can smell completely different, and why some unrelated molecules share an uncanny scent. Your sense of smell, then, may be less about shapes in space and more about songs in time. Think of it. Every fragrance you've ever loved, fresh rain, morning coffee, the perfume of flowers, may be the result of quantum notes played upon the strings of the universe. Your nose, quietly, is a musician of vibrations. Now let us rise into the sky. Imagine a bird on its long migration, gliding over seas and mountains, guided by an invisible map. How does it know where to go? The answer may lie in quantum entanglement. Inside the eyes of migratory birds, there are special molecules called cryptochromes. When struck by light, they release pairs of electrons that remain entangled, linked in a quantum embrace no matter the distance. These entangled electrons respond differently depending on the Earth's magnetic field. They whisper to the bird's nervous system, creating a faint visual pattern, an inner compass drawn in quantum ink. The bird sees not just the world of trees and rivers, but also a hidden map of magnetism stretching across the globe. And perhaps, in some quiet way, humans still carry echoes of this compass. Some studies suggest we too can faintly sense Earth's magnetic field, though the feeling lies buried, forgotten beneath modern life. The next time you stand outside and feel a tug toward the horizon, consider, maybe it is the quantum within you, softly reminding you that you belong not only to the ground beneath your feet, but to the planet's great magnetic song. Memory is the soft echo of time within us. It is the invisible library where every joy, every sorrow, every fleeting moment is gently stored. But what if the shelves of this library are built not only of neurons and synapses, but of quantum whispers hidden within their delicate machinery? Some scientists have wondered, could the secret of memory reach down to the quantum scale? Molecules in the brain, such as microtubules inside neurons, might act as tiny quantum processors, able to hold patterns of information in states more subtle than electricity alone. The way a note reverberates long after a string has been plucked, so too might quantum vibrations help memories endure. Think of how a single scent, a faint trace of rain on warm pavement, or the sweetness of childhood bread can bring back a moment decades old. That flash of recall feels less like a file being opened and more like a quantum spark leaping across time, a resonance between the present and the past. In this view, memory is not a rigid archive, but a shimmering dance of probabilities, forever reshaping itself as we remember, forget, and remember again. Each recollection is not a replay, but a recreation, a new quantum ripple stirred by the past, unfolding in the present. And perhaps when we dream, these ripples move most freely, allowing the mind to wander through corridors of possibility, where forgotten doors reopen and silent stories awaken. Memory, then, may be less about storage and more about resonance, a quantum song that plays across the hidden chambers of the mind, reminding us that we are not merely creatures of matter, but beings woven from echoes, vibrations, and time itself.
And so, dear listener, we arrive at the edge of our journey. From the trembling whisper of a photon guiding a bird across continents, to the delicate quantum pirouette of enzymes within our cells, we have seen how life is stitched together by threads so fine, they almost escape notice. Quantum biology reminds us that existence is not rigid or mechanical. It is fluid, improvisational, and deeply mysterious.
Life is not simply chemistry in motion. It is a subtle dance, choreographed in part by the strange laws of the quantum world. Perhaps this is why we feel a sense of wonder when we pause to look at the stars, or a shiver of awe when we consider the microscopic world within us. We are not merely observers of the universe, we are participants in its ongoing symphony, a melody that stretches from the spin of an electron to the unfolding of consciousness itself. As you drift toward rest tonight, you might imagine your breath as part of this great rhythm. Inhale, and you draw in starlight made solid in your body. Exhale, and you release yourself back into the flow of the cosmos. You too are quantum. You too are part of the dance. And if you've found calm in tonight's journey, I'd love for you to subscribe to The Wandering Neuron, so we can continue traveling together through science, through wonder, and through the quiet mysteries that surround us. For now, let your thoughts grow softer, let your body feel lighter, and let sleep arrive gently, like a slow, kind tide. Good night, and may your dreams carry you deeper into the endless dance of life.